Hi there. I want to talk more on types of reactions in this video. Redox reactions is when there is gain or loss of electrons, which I cover in another video. Precipitation reactions are those that form insoluble compounds from soluble ionic compounds. An acid-base reaction, also called neutralization reaction, will always produce salt and water, and it is a reaction that occurs between acid and base. Here is an example of a precipitation reaction. You have silver nitrate reacting with sodium chromate, and you form a precipitate here. So what you have is silver nitrate reacting with sodium chromate, and what you form is silver chromate and sodium nitrate. We are told that this is an aqueous solution, so what that means is that in solution silver ions and nitrate ions are free. Sodium chromate is soluble, so here you have sodium ions and chromate ions, which are free. Now what happens is that silver, instead of combining with sodium, can combine with chromate, and it forms an insoluble compound, silver chromate, and that's an insoluble compound that is shown right over here. And the sodium and the nitrate will combine, but because they are both soluble, they will remain as ions in aqueous environment. So this is an example of a precipitation reaction. Before I proceed, I want you to be familiar with solubility charts like this. Let's just go over some of the general rules that will help us guide how to decide which of the compounds will precipitate and which ones won't. All common compounds of group 1A ions like lithium, sodium, potassium, etc., and ammonium compounds are soluble. All common nitrates, acetates, perchlorates are also soluble. All common chlorides, bromides, and iodides are soluble except silver, lead, copper, and mercury. All common sulfates are soluble except for those of calcium, strontium, barium, and lead. So this is a general guide to decide which of the compounds are generally soluble. Compounds that are generally insoluble, all common metal hydroxides are insoluble, except for group 1 and the larger members of group 2. All common carbonates and phosphates are generally insoluble, except for group 1 and ammonium. All common sulfides are insoluble, except for those of group 1 and group 2 and ammonium. Let's look at the definition of acids. Acid produces protons, and base produces hydroxide ions. So if you have a compound, if you dissolve it in water and you produce a proton plus an ion, for example, you may have H2SO4, and if you dissolve some sulfuric acid in water, and if you get a proton plus HSO4 ion, and if it's an ion, it should always be in an aqueous environment. We know that this is an acid. Now, base like sodium hydroxide, when dissolved in water, will always produce hydroxide ions. And that's how we recognize the compound as acid or bases. There are other definitions as well, which we will cover later, but for now, let's just say that acids are proton donors and bases are proton acceptors. I want to remind you that a proton is a simple H+. Here's an example of how acid-base reaction can be performed. You can put either an acid or a base in the burette, or acid or base in the conical flask, and you can titrate the acid with base or base with acid until we reach a neutralization point. Other types of reactions that we encounter are combustion reaction, synthesis and decomposition, single and double displacement. It is easy to decide if a reaction is a precipitation reaction. Just look for the formation of insoluble salts. To decide if a reaction is combustion, look for oxygen in the reactant, and the product should always be carbon dioxide and water. And this compound that is being combusted or burned is usually a hydrocarbon. For example, you could have C2H6 combining with oxygen, and it produces carbon dioxide and water. I recognize this as a combustion reaction because I have oxygen in the reactant and my products are carbon dioxide and water. So we should always balance the equation. So this is the balanced equation for the combustion of ethane. Acid-base reaction will always have a proton involved. There is always hydrogen transferred from an acid to a base, and the product is always salt and water. For example, you can have hydrochloric acid reacting with sodium hydroxide, and you will produce sodium chloride and water. This is your acid, and I know it's an acid because it will produce protons in water. This is my base, and I know this is a base because it can produce hydroxide in water. This is my salt. I know this is a salt because it's an ionic compound, and this is water. Another example would be sulfuric acid plus ammonium hydroxide. And this time I want to explain a little bit further. I will have 2H plus and SO4, 2 minus, because sulfuric acid is completely soluble in water, and in aqueous environment the ionic species, just like in precipitation reaction, will be freely floating around. And similarly, we learned that ammonium compounds are soluble, so in water ammonium ions and hydroxide ions will be freely floating around in an aqueous environment. So what can happen, much like the ionic reaction, we can combine the ammonium sulfate, which is the salt, and the hydroxide and hydrogen will combine to form water. So our product is going to be ammonium sulfate and water. And if I was given this reaction here, I would identify first sulfuric acid as acid, and I would identify ammonium hydroxide as base. And this is an ionic compound, so this is salt and water, so I will call this neutralization reaction or acid-base reaction. Two more types of reaction that you will encounter is synthesis and decomposition. When one compound forms two or more compounds, we call this decomposition, and the reverse would be synthesis. For example, when phosphoric acid produces tetraphosphorus decaoxide and water, we will recognize this as a decomposition because you have one compound producing two compounds right here. So we should balance this equation. We should not leave any equations unbalanced. I would recognize as decomposition reaction. For synthesis, we typically have the reverse of decomposition. So two compounds, two or more, combine to give a single compound. For example, if you have nitrogen combining with hydrogen to form ammonia, this is synthesis reaction. And finally, we have displacement reactions. You could have single displacement or you could have double displacement reactions. Here's an example of a single displacement reaction. In a single displacement reaction, you could have a single element combining with an ionic compound, forming a new ionic compound, and displacing an element out. So the second one is an example of a double displacement reaction. So here's an example of a single displacement reaction. If you have copper reacting with silver nitrate, and if you produced copper nitrate and silver, this is a single displacement because you can see that copper displaced the silver. Here's an example of a double displacement reaction. Each one of this is in an aqueous environment, including the single displacement. You can see that the lead has now displaced sodium to form lead sulfate, and sodium has displaced lead. So this is a double displacement. So let me just label this here. This is an example of a single displacement, and this is an example of a double displacement. Okay, now let's go ahead and summarize what we have just covered. Looking at this reaction, if we needed to identify the type of the reaction, let's look at it very carefully here. I notice that this is an ionic compound and it's soluble because there's aqueous here. This is an ionic compound and it's soluble. And I formed a precipitate here. And I also noticed that the calcium replaced potassium and potassium replaced calcium. So this is a precipitation reaction and double displacement. Here I look at a hydrocarbon, one of the reactants is oxygen, and I produced carbon dioxide and water. This is how we recognize combustion reaction, so this is identified as combustion reaction. Barium hydroxide and sulfuric acid. Because barium in water will produce hydroxide and sulfuric acid in water will produce protons, we immediately know that this is base and this is acid. Check to see the product. You do have salt and water, so this is acid-base or neutralization reaction. Aluminum reacting with lead nitrate gives me aluminum nitrate and lead. It looks like it's a single displacement. Aluminum displaced lead. Lead came out as a pure element, and we have formed aluminum nitrate instead of lead nitrate here. So this would be single displacement. Not precipitation, because we're not really precipitating any insoluble salt here. One compound, hydrogen peroxide, forming water and oxygen, two compounds. This would be identified as a decomposition. Two elements combining to form a new compound. This is combination or synthesis. Thank you for listening. I'll see you again. Goodbye.